Welcome, ladies and gentlemen, to your Part B of your Section 6.1 notes. This is where all the fun begins because we're going to apply what you just learned from Section or Part A. So it says up here, it says, by the way, you definitely want to write this on the top of your note guide so it helps us out when we're referencing things later on. Some of these note guides get a little lengthy and it's nice to know which part we're dealing with. Anyway, so it says use trig ratios, so the ratio of side lengths, to find missing the side lengths that you want to find. So that kind of sounded weird, but use trig ratios to find missing side lengths. So here we have Rachel, who is standing 5 meters from the base of the flagpole. She looks up at the top of the flagpole at an angle of 25 degrees, and that is an example of angle of elevation because she's looking at the horizon then elevating up to the top of that flagpole. That comes up quite a bit later, so I wanted to kind of start using those words. So we have a 25-degree angle of elevation. If Rachel's eyes are 1.25 meters above the ground, how high is the top of the flagpole? Round to the nearest hundredth. So this is actually pretty old school. You would have been able to do this even before my little note guide. Again, stemming from geometry. So really, she wants to know what the length of that flagpole is. We already know what this length is right here. That's 1.25. What we need to know, and I'm going to switch colors because I can, and it's super cool, is this right here. We need to figure that out so we can add it to the 1.25, which I kind of jumped the gun here. Let me write that 1.25 meters right there. And here we are. So I know if I am given 25 degrees, this is clearly my right angle, and that 25 degrees and that red side are opposites. They're opposite of each other, so I know this is the opposite side length. And the other side I know, well, the only side I know actually, is this length right here, which is stemming from that 5 meters from the information given to us. So we want to know our opposite. We are given an adjacent side, so opposite and adjacent is clearly tangent. So we're talking about tan of 25 degrees is equal to the opposite side, and I'm going to just, you can call it whatever you want. I'm going to call it h. So I'm going to actually label this as the variable h for height over the adjacent side of 5. And so we've just created, using our trig ratios, and the angle, I'm putting this over 1, and at this point you can cross multiply to solve for that height. Now you may have been taught to multiply both sides by 5, that's fine. You can solve this a couple different ways. I'm just telling you, you have a proportion here, so I tend to teach it as that height is equal to 5 times the tan of 25 degrees. And when you calculate that, make sure your calculator is in degree mode, so hit mode and make sure you're in degree mode. There's this thing called radians, which I'm teaching you in a couple sections. It'll give you the wrong answer. So once you do this, if you're getting that the height is 2.33, that's excellent because that's exactly what you should say. And of course it's not 2.33, it's 2.33 meters. Now with that said, that's the part of the red flagpole. Now we want to add the two lengths together. And when we add the 1.25 meters plus the 2.33 meters, we end up with the height of the flagpole is 3.58 meters. And these kind of problems, notice it did say round to the nearest hundredth, so we're doing that. And of course it's an application problem, so we put a unit on it. Would you get it wrong on an assessment? The answer is yes, you will. You'll get a ½ point off for leaving off the unit, and you will get a ½ point off if you don't round right. So you want to make sure you do those, otherwise you get piddly points off and it doesn't feel very good. So just make sure you watch those instructions. Okay, so inverse trig ratios. This is actually having to find the angle. Now we've been focusing on side lengths, but we haven't actually talked about calculating the angle. And you did again this in geometry. Notation, this right here is saying, hey, means what angle has a sine ratio of 0.5. So you use your inverse sine, and don't say sin. Sin is not what you say. You say sine. It's kind of like avenue. You don't say av, you say avenue with abbreviations, or there's a million other examples. But anyway, so you here, this is telling me that when you're taking your inverse sine of 0.5, you want to find the angle. So anytime you see that inverse sine notation, think angle. And on your calculator, of course, you use the inverse sine, which is the second sine button. It'll push you up to that second level, which will be sine inverse 0.5. What angle has a sine of 0.5? Well, do it in your calculator right now. You can pause this video if you want. But when you do the inverse sine of 0.5, as long as you're in degrees, you'll end up with 30 degrees. So again, pause this video, make sure you're getting that in your graphing calculator so that you know as we move forward you're getting the right answers, especially when you're doing your work. Okay, so example number 4. You're standing 12 feet from the base of a tree that is 10 feet tall. So we know that the base from here to here is 12 feet. We know that the tree itself is 10 feet tall. And it's asking at what angle are you looking up at the tree? So we're trying to find this angle of elevation right here. And again, notice it says angle of elevation is measured from the horizon up. So here it has a hint. You are looking for the angle that has what trig ratio? And what I tell students is when you're trying to find the angle, you need to use the side lengths that are given. So if you look at this, this is the opposite to the angle that you want, and this is the adjacent to the angle that you want. And a lot of times I even say star the angle you want, so you know that that's where you're focusing in on. And opposite adjacent is definitely tangent. And we do seem to always use tangent a lot. But anyway, tan of x degrees is equal to the opposite side, which is 10 over 12. Now, when you find, in order to actually solve this, you need to, because you're finding an angle, you are doing your inverse tan. Again, when you're trying to find an angle, you always use inverse sine, inverse cosine, inverse tan in this case. So when you do the calculation, again, make sure that you're getting this answer. And I'm going to put it right here. X equals 39 point, what did they say to round it to? They didn't say it. So if they don't say it, that's when I round to the nearest hundredth. So advanced algebra is to the nearest hundredth, 2 decimal places. Pre-calculus is thousandths, 3 decimal places. So you'll see there's a difference in those classes. And in this case, we're going to do to the nearest hundredth unless they say otherwise. Okay, 39.81 degrees is the angle of elevation. Okay, so what's going to happen here, down here, it says solve right triangles. I'm going to leave it right here. Solve right triangles says use the Pythagorean theorem, trig and inverse trig to find all the missing sides and angle measures. Round to the nearest tenth. See, they're changing the rules. If it says it, you round to however they want. Now, anytime you hear solve a triangle or solve a right triangle, it means find all missing angles and side lengths. And that is, again, consistent from geometry. Now, looking at this, these two are right triangles. I'm going to say this is the one you're going to do for me to prove to me that you know how to do it. I'm going to demo example number 6. So when you come in and check this off, I'm looking to make sure the work and the answers for example 5 are correct. So I'm looking at this down here, this example number 6, and I have 2 side lengths here. I need the third side length and I need some angles. So I'm going to first, I'm going to find the angle measure for, I don't know, actually let's find the length of the sides because that's pretty straightforward. This is going to be the hypotenuse, and so it's the longest side. So if you have 2 of the 3 sides of a right triangle, you definitely use Pythagorean theorem. So here we go, and since this is the hypotenuse and it's directly across from the angle C, we want to get really used to starting to label it properly. And so while I understand they're using AB here, BA, which is this length right here, when it comes to variables, I'm looking at across of it, I'm going to put a little baby c. Just like if this is angle B over here, this means this is side B over here, and we use lowercase b. And then 8 over here, we would use little lowercase a to represent that. So that's kind of just getting you again used to where we're going to be going. So example 5, you're going to be finding this little side, actually big side, and that's angle or side B, which is the same thing as CA. So always the side and angle across are related as far as when you're naming it. You use lowercase for side lengths, uppercase for angle measures. Okay, so Pythagorean theorem, here we go. very quickly, put 8 squared in your calculator plus 15 squared. That's going to get, and then square root that. And I know you know how to do this. Otherwise you wouldn't be in my class, right? And so when you take the square root of it, you get 17. So length AB or BA is 17. So I don't want to be too redundant on you guys. Now with that said, notice there's no units. If you want to put a unit, if you want to make up a unit, that's fine. Since there's no unit, I'm just going to leave it just like that. Now comes for the part where you're having to find an angle measure. You just need to decide which angle you want to find first. I'm going to switch colors here again because I can. A sounds better to me, so I'm going to find angle A. I'm putting a star there because that's the one I'm going to focus on. Now, I've got all sorts of stuff here, so I'm going to get rid of that so it doesn't get all cloggy. But here's what I'm going to say is if that star is the angle that I'm finding, I'm going to find this one here, I know that this is the opposite side of that angle A and this is the adjacent side. How do I know? Because this is the hypotenuse, which is the longest side across from the 90-degree angle, and opposite is directly across from the angle we're trying to find. Now those opposite adjacent is what we have. So again, notice we have another tangent. So tangent of angle A equals, notice I'm using big letter A because that's an angle, is equal to the opposite side 8 over the adjacent side 15. Do your inverse tan on that. And you'll find that your angle measure should be 28, that's an equal by the way, 20, ooh my goodness, my handwriting you guys, oof, I can do better. 28.1, because we're talking to the nearest tenth, so this is 28.1 degrees, I'll put a degree symbol up there. And now to find that angle B, folks, that's where we could set up a whole other ratio if we want, but why? When you know that triangle is 180 degrees and one of those three angles is 90 degrees, so you can just say, hey, you know what, angle B is going to equal 90 minus the 28.1, or you can go 180 minus the 90 minus the 28.1 degrees, and you will get an angle measure of 61.9 degrees. So that is an example of how you solve or find all missing pieces of a right triangle. And again, example 5 is on you to do to show me that you are understanding it. Thanks for tuning in, and if you have any questions, you'll have time in class to ask. Take care.